Rising up out on the street, doing some calculus related rates of what we're working on today. And this is the final day. Bow, bow, bow. Sorry, I'm just in a really good mood today. Let's rock and roll. This is Related Rates Day 5. Star! Related Rates Day 5. Okay, really, we're just going to go over the homework and do one final problem. So we're pretty much done with this topic. Today is Monday, Lunedì, I think. Tomorrow is Tuesday, Martedì, followed by Mercoledì. After that, I have no idea. Anyway, tomorrow you will, even today, instead of homework, you'll be given a take-home assignment you can work on tonight. Going to give you the day to work on it tomorrow, trying to help you guys out. And then we're going to get into integration on Wednesday. So I hope you tried your homework. 6 actually should have been pretty easy, pretty classic type of problem. The only thing that's a little wonky, little wonky, Oompa Loompas, is that you got to know that this sphere is decreasing. Okay, the radius is decreasing, so the dr of dt, the rate of change of the radius, should be negative. If you didn't make it -2, if you left it as +2, you got your answer as positive 48 pi, and then you probably circled C anyway. This would be a much better problem if there was a positive 48 pi as one of the answers, because it's important to know, they wanted to know what's the rate of change in square centimeters per second of the surface area of the sphere. And you know, if the radius is getting small, the surface area is getting smaller, but they didn't say how fast is the surface area getting smaller, because then you'd want the absolute value. They actually said the rate of change, and that's what they usually ask for in the AP exam. This is an AP problem right here, part 1 problem. They want to know the rate of change. Remember, if something is getting bigger, its rate of change is positive, and if something is getting smaller, its rate of change is negative. 7's a cool problem, another cube problem. Should be easy to do. Make sure you know how to get the volume of a cube. If each side is x, the volume is x cubed. They didn't ask for surface area here, but the surface area of a cube, each of these faces has an area of x squared, right? X times x, and there's 6 of them. That would be 6x squared. Sometimes that shows up on problems, okay? So just things that you should be able to think about. But once again, the cube's pretty much as easy as the sphere, because it's only univariable on either side. Number 10 was a great problem. It's an old school AP problem. I think it's from 1983, believe it or not, when I was 4 years old. Actually, 3 years old. I was turning 4 in like a month. My birthday's June 30th. A month, 2 months. Anyway, so this one right here was really cool. Part A should have been a piece of cake. It's the ladder leaning up against the building. You should have got a negative value for B because the ladder's sliding down, so B's getting smaller. Part B was cool. Oh, by the way, I used A and B here. You could use X and Y, but be careful because they used X and Y. You could use lowercase x and lowercase y. You'd probably be all right. Some people use OY for this. They're like, I want DOY over DT, DOY over DT. You could do that. It just gets a little annoying. And then you want to use that value for part D because now they want the rate of change of the area, and that's what we talked about on Friday. And you need to use the product rule right here, okay? And remember, when you use the product rule, dB over dt is going to show up, and dA over dt is going to show up, but I have dA over dt, and I got dB over dt in the previous problem. You could here, if you want, solve for A in terms of B in this formula right here. You could say that A is equal to the square root of the quantity, 225 minus B squared. And you could do it that way, but then it becomes a really annoying product rule as well. But it's only one variable, so you might like that better. I'd go with this one right here. Hopefully not too terrible of a problem. Let's do one more related rate. Hopefully you downloaded that file. You're either looking at it or you have it printed out. I get it. I know printer ink is expensive, hard to come by these days. Hard to get stuff on time shipped, and you know, just having a printer at home and having paper. So that's why you could just look at this on your little Chromebook, and then you could write your answers out in your notes. Cool problem right here. This might freak people out, not because of the related rate, but because of other things in the diagram below. Look out below! The y-coordinate of P is increasing at a rate of 4 units per minute, while point Q remains fixed in its position. So point Q is here, and this point P is increasing at a rate of 4 minutes per minute. So every time, a minute elapses, this thing goes up 4 boxes, 4 units. So really what's happening is that this distance is getting longer and this distance is getting longer, but this distance is actually remaining constant. And I know what it is. If this is the point 4, 0, this distance is 4. This is changing. I'm actually going to call him Y because that's what this distance is, okay? You know, this distance right here is the y-coordinate of this point. This also gets bigger as well, but that's not what they're talking about. They're not talking about the hypotenuse. They're talking about this angle, which is actually going to increase, right? As that distance y gets bigger and bigger. Now they actually want you to find the rate of change of angle theta in radians per minute, radians, when y is equal to 20. So at the instantaneous moment, this thing is at the point 0, 20. What's the rate of change of this angle right here? So trig is going to be involved. Don't forget this piece of given, though. They told us that y was changing or increasing at a rate of 4 units per minute. So dy over dt equal to 4 units per minute. It's the best I could do for my units right there. And what do we want? Well, we want d theta over dt. Don't be a theta heta when, and now we know when y is equal to 20. So the setup should be very doable, not very different from problems we've done in the past. The problem is coming up with a formula that relates these two variables. It better have a theta in it, and you probably also want to have a y in it as well. And this is tricky. People are like, how the heck am I supposed to get a formula that involves an angle of a right triangle? I don't know. Think about what you learned back in like 7th grade or 8th grade. I guess it was probably 7th grade, or maybe geometry, right? Common Core geometry. I think they do SOHCAHTOA, trig of the right triangle. And you can see that they don't tell us anything about the hypotenuse. If you start here, they tell us about the opposite side and the adjacent side. That's the TOA of SOHCAHTOA, and that's tangent equal to opposite over adjacent. So I know the tangent of theta, it's a tan theta, a theta hanging out in Aruba, is equal to the opposite side over the adjacent side, which is y over 4. And that means tan theta is actually equal to, instead of y over 4, 1/4 y. You know, why would I do that? You tell me. Why would I rewrite it that way? Very good, because I have to differentiate both sides, and this is easier to take a derivative of. So look, it's still maybe not the worst thing in the world, but now when you differentiate both sides, do you remember what the derivative of tan theta was? Or how about tan x? You better know it's secant squared x. So the derivative of tan theta is going to be secant squared theta. But I just took the derivative of a function whose argument was not one single x. I got to multiply by the derivative of the argument, okay? Or one single t in this case. You know, look, you have to multiply by the derivative of theta with respect to t, which is d theta over dt. That's the implicit differentiation part. That's the chain rule part. The derivative of 1/4 y is 1/4 dy over dt. All right, so maybe that's slightly snark house right there, but not nearly as snark house as this moment right here, because now we want secant squared theta. Remember, that's secant theta quantity squared. And d theta over dt, see, I don't know what he is, which is fine, okay, because that's what I want to solve for. But you know it's equal to 1/4 times dy over dt. And the thing is, I know what dy over dt is, okay, I know it's actually equal to 4. I don't know d theta over dt. The problem is I got to figure out what theta is equal to at this instantaneous moment when y is equal to 20. And here's what, to quote Anakin Skywalker, this is where the fun begins. That and no! But that's after he became Darth Vader. So anyway, you know, what happens here? Well, when y is equal to 20, what does this diagram look like? We know y is equal to 20 right here. We know this is 4. How are you going to figure out what theta is? You're going to have to use this formula you set up right here and say the tangent of theta is equal to opposite over adjacent 20 over 4, which means the tangent of theta is equal to 5. And people are like, oh, great, Berto, how do we solve for theta? Well, you know how to detach tangent from theta? Bring out tangent inverse, right? Or arctan. We did this earlier in the year. I'll say tan inverse. I'm going to make both sides an argument of tan inverse. If you do it to one side, you got to do it to the other, said the cow. So I put the 5 inside here, okay, and here's the closed parenthesis. It's kind of off screen right now, so I think you can see it right there. I wish I had a more, comprehensive setup than my, my emergency peanut butter supplies over here for my quarantine. I wish I had, it set up where I can go from the computer screen to the paper to my face, right? You can see my face. Hi, but this is nice because I don't even have my hair done. It's really just a complete mess. So I don't want you to see my face right now. You guys are probably sitting here listening to this in pajamas. No, you're probably listening to it like 11:30 at night. Get up early in the morning, you crazy people. So over here, tan inverse of tan theta is just theta. And then people are like, oh, theta equals tan inverse 5. Thanks, Berto. Well, I forgot to tell you this problem right here. Little star. Calc assist. Calc assist. And you need the calculator to get to know what the tan inverse of 5 is actually equal to. And it's going to be a nasty irrational value, radian mode, radian mode, radian mode, radian mode, Radian mode, always for this class, radian mode. Never be in degree mode. I don't care about physics. Well, I do, but you know, don't put yourself in degree mode. Radian mode. Sorry, I had a lot of coffee this morning. Let's do a little tan inverse, fish inverse, okay, of 5. And you can see, nasty, oh, is error syntax. What did I mess up? What is this Gatto? Oh, how about you put something in there? Did I just hit that button so quickly that, you know, it couldn't even, I was so rapid, you know, that it couldn't even actually, measure, actually input my movement right there. It was my last name, Allen, my first name, Barry. It's easier to know now because they came out with Justice League, but, you know, that's the Flash. Anyway, that nasty value, let's do this. Let's store it in for like alpha A or something like that. So I'm actually going to say that. Or you know what? You could store it in for theta. It's a bad idea. Let's just use A right here. Okay, and I'm going to do this. I'm going to now say that A is equal to the tan inverse of 5. And the only reason I'm doing that is then I could put A right here. You don't need to do that. You could put tan inverse 5 there. You could even put theta right there if you want to, right? You could leave it as theta. It doesn't make a difference. But remember, this is 1. And this side over here, 1/4 times 4. I'm going to divide by secant of A quantity squared, or secant theta quantity squared, to get what d theta over dt is equal to. And now I could use my calculator. Actually, you could leave it like this if you want. It's not wrong. It's the complete answer. It's probably a better answer. But let's go decimal here. Well, alpha y equals for shequis. 1 over, oh, how about this? I can't use secant in my calculator. Okay, so I'm going to say this is 1 over secant squared A, right? It's the same way to write it. You could do something like that. And 1 over secant, it's really cosine, right? So cosine squared A. So really just cosine A quantity squared. So cosine of alpha A, let's quantity square that sucker. And I get 0.038. So I had a dog named 0.03. I fed him 0.038 units. I need units. Theta is measured in, they actually told you radians, and they even told you d theta over dt is in radians per minute. So radians per minute, not really too difficult as far as units are concerned. And people are like, oh my God, in the take home, we have to worry about this crazy trig and stuff like this. No, not really. Okay, not that this is bad. This should not be an issue. This over here, you should know how to do it. We talked about this earlier in the year. This should not be an issue. The hardest part of it might just be actually, coming up with this original formula right here. But really, taking the derivative tangent, you should know how to do. It's not a problem you often see, but it has shown up before in the AP exam. It's been a long time. I think the last time something like this showed up, 2003 maybe. Just thinking about it, drinking my coffee, my own, my precious. So I wouldn't freak out so much about it. But once again, related rates, now nothing is focused. There we go. Related rates, not too terrible. If you have questions on these problems, like I said before, please text me or remind, or, send me an email or something like that with some screenshots and we'll talk. And that's the end of the topic, okay? So today's Monday, tomorrow's Tuesday. You could work on the take-home tonight. You could work on it tomorrow. It's due tomorrow by midnight. Then we'll get into integration. I hope you're safe. I hope you're healthy. I hope you're happy. I hope you're playing video games. Great way to pass time during quarantine, but you better also be doing your work, okay? And this is Mr. Berto once again signing out. See you soon, I hope. Adios.